We like to believe that our planet is fully mapped, fully explained, and fully understood. Satellites orbit above us every second. Cameras scan every corner of the surface. Data flows constantly, telling us what the Earth is made of and how it works. And yet this confidence is an illusion, hidden across continents, oceans, deserts, and ice fields. There are places that do not behave the way they should. Landscapes that appear artificial, colors that seem impossible, phenomena that look less like nature and more like glitches in reality itself. Some of these places were formed by forces far older than humanity. Others exist because of human interference, and a few continue to change right now, slowly rewriting the rules of geology, biology, and physics as we watch. These are not tourist postcards. They are not simple curiosities. They are reminders that Earth is not a static planet. It is a living system, unpredictable, experimental, and sometimes unsettling. Today you are about to journey through some of the strangest places on the planet, places that confuse scientists, challenge logic, and force us to question how well we truly understand the world beneath our feet. From deserts that seem digitally rendered, to ice that bleeds, to landscapes that look designed rather than formed. What you are about to see is real, and once you see it, reality may never feel quite the same again. In the vast emptiness of the Nevada desert, where the land stretches flat and dry beneath an unforgiving sky, there is a structure that feels completely out of place. At first glance, it looks artificial, almost synthetic, as if it were generated by a computer rather than shaped by nature. Bright reds, vivid greens, glowing yellows, and deep oranges spill over a growing mound of rock, creating patterns that appear too deliberate to be accidental. This is Flygeyser, and what makes it truly unsettling is that it was never supposed to exist. The story begins in 1966, when workers drilled into the ground searching for water to support agriculture in this harsh environment. The drilling was unsuccessful, and the well was eventually abandoned. But beneath the surface, something had already been disturbed. Pressurized geothermal water, trapped deep underground, remains sealed, waiting. More than 40 years later, in 1960, that pressure finally found a weak point. Superheated water burst through the surface, carrying with it a mixture of dissolved minerals and microscopic organisms adapted to extreme heat. Unlike natural geysers, which erupt intermittently, Flygeyser began releasing water continuously, day after day, year after year. As the hot water flowed into the open air, minerals such as calcium carbonate started to harden and accumulate. Layer by layer, they built upward. Slowly, almost imperceptibly, a new geological formation was born. Not through natural balance, but through persistent imbalance. The colors that make Flygeyser so striking come from thermophilic bacteria, microorganisms that thrive in hot, mineral-rich environments. These bacteria form thin biological films across the surface, each species contributing its own pigmentation. Greens, reds, and oranges spread outward, transforming the structure into something that looks alive. And in a sense, it is. Flygeyser continues to grow. It continues to change shape. It continues to reshape the surrounding land. There is no eruption cycle, no dormant fate. It pulses quietly, releasing warm water into the desert air, slowly expanding its reach. What we are witnessing here is not a natural wonder in the traditional sense. It is a reminder of how fragile equilibrium can be. A single human action, one abandoned well, was enough to trigger a process that has now lasted more than a century. Flygeyser stands as a monument to unintended consequences. It blurs the line between human error and natural creation, and it forces us to confront an uncomfortable truth. When we interfere with the Earth, we may start processes that cannot be undone. In the silence of the Nevada desert, Flygeyser continues to grow, quietly, relentless. Out there, farthest at the edge of the planet, where silence dominates and life appears impossible, Antarctica stretches endlessly in white. Ice blankets the land in every direction, reflecting light so intensely that the horizon itself seems to dissolve. Temperatures plunge far below freezing. Winds cut across the surface with relentless force, and the environment feels entirely hostile to anything living. And yet, in this frozen wilderness, there exists a sight so unsettling that it feels almost wrong. From the side of Taylor Glacier, A deep red liquid slowly pours down the ice, staining the pure white surface with dark crimson streaks. It looks disturbingly organic, as if the glacier itself were wounded, as if the ice were bleeding. This phenomenon is known as blood falls. Discovered in the early 20th century, blood falls immediately baffled scientists and explorers. In a place where everything is frozen solid, the presence of flowing liquid alone was a mystery. The color only deepened the unease. For decades, theories ranged from algae to unknown biological processes, but none fully explained what was happening beneath the ice. The truth revealed through years of research is even more extraordinary. Deep beneath Taylor Glacier lies an ancient reservoir of water, sealed off from the outside world for possibly millions of years. This water does not freeze despite Antarctic temperatures, because it is extremely saline, far saltier than ocean water. The salt lowers the freezing point enough to keep the liquid flowing in total darkness, under immense pressure and without contact with the atmosphere. This hidden water is also rich in dissolved iron. When cracks within the glacier allow the water to escape, it slowly emerges onto the surface for the first time in geological history. The moment it meets oxygen, a chemical reaction occurs. The iron oxidizes, turning the water a deep blood-red color. What we see cascading down the ice is not blood but rust. Yet the color is only part of the story. Within this ancient water live microorganisms that have survived in complete isolation, without sunlight, without plants and without oxygen. These microbes metabolize iron and sulfur instead of relying on photosynthesis, existing in conditions once thought incapable of supporting life. They have adapted to darkness, pressure, cold, and chemical extremes that would instantly kill most organisms on Earth. Blood Falls is not just a strange visual anomaly, it is a natural laboratory, a glimpse into ecosystems hidden beneath ice sheets. And more importantly, it offers a powerful analogy for environments beyond our planet. Scientists study blood falls because it mirrors conditions that may exist beneath the icy surfaces of moons like Europa or Enceladus. If life can survive here, sealed away, starved of light, isolated for millions of years, then life may exist in places we once dismissed as completely lifeless. Standing before blood falls forces a shift in perspective. Antarctica is not just a frozen desert. Its ice is not inert, and beneath its surface the planet is still active, chemical and alive. What appears to be bleeding ice is in reality a reminder that life does not always need warmth, sunlight, or comfort. Sometimes it only needs time, and in Antarctica, time moves slowly. In the eastern shadow of California's Sierra Nevada mountains, there is a lake that seems frozen in time. Its waters shimmer in the sun, but something about it feels unnatural. The air is quiet, the shoreline is pale and mineral-crusted, and rising from the water, like the ruins of an ancient civilization, stand towering stone formations that appear sculpted rather than grown. This is Mono Lake. At more than 760,000 years old, Mono Lake is one of the oldest lakes in North America. Long before modern humans existed, before cities, before agriculture, this basin was already collecting water. But unlike most lakes, Mono Lake has no natural outlet. Water flows in, but it never flows out. Instead, it evaporates. Over hundreds of thousands of years, this slow evaporation caused salts and minerals to accumulate to extreme levels. The lake became highly alkaline, creating an environment so chemically aggressive that most life forms simply cannot survive. And yet, life adapted. The most striking features of Mono Lake are its limestone tufa towers. These eerie spires rise from the lake bed, some reaching more than 30 feet into the air. They were formed when freshwater springs, rich in calcium, bubbled up from beneath the lake and met the carbonate-rich alkaline water. At the point of contact, a chemical reaction occurred, precipitating limestone that slowly built upward, centimeter by centimeter. For centuries, these formations remained hidden beneath the surface. But in the 20th century, human intervention altered the lake dramatically. Water was diverted to supply the growing city of Los Angeles. As water levels dropped, the tufa towers emerged, exposing a ghostly landscape that had never been meant to see the open air. The lake itself changed. Salinity increased, shorelines retreated, entire ecosystems were pushed to the brink. Mono Lake is inhospitable by most standards. Its waters can burn unprotected skin. Its alkalinity rivals household cleaning agents. Fish cannot live here, plants struggle to survive, and yet, trillions of brine shrimp and alkali flies thrive, forming the foundation of a delicate food web that supports millions of migratory birds each year. From a distance, Mono Lake looks still and lifeless. Up close, it is chemically active, biologically resilient, and constantly changing. The stone towers feel ancient, but they are products of ongoing reactions between water, rock, and time. Standing at the edge of Mono Lake feels like stepping onto another planet. The colors are muted, the shapes are unfamiliar. The rules of biology seem rewritten. This lake is not merely a geological curiosity. It is a warning, a demonstration of how fragile balance can be when water is removed from a closed system. And it is a reminder that some environments survive, not because they are gentle, but because life has learned to endure extreme. Mono Lake does not welcome visitors. It does not comfort. It simply exists on its own term. On the rugged, northern coast of Ireland, where the Atlantic Ocean crashes relentlessly against dark cliffs, the ground itself begins to change. The shoreline loses its randomness. Chaos gives way to order. Stone becomes geometry, and the land starts to look less like nature and more like design. This is the Giant's Causeway, stretching from the base of steep cliffs into the cold Atlantic waters. More than 40,000 stone columns rise from the earth in tightly packed formations. Most of them are hexagonal. Some have 5 sides, others 7 or 8. Together, they form a natural pavement, so precise that it feels engineered rather than formed. For centuries, this place defied explanation. Local legends told of giants who built a bridge across the sea, connecting Ireland to Scotland. According to the myth, the stones were placed by a giant named Finn McCool, whose massive footsteps shaped the land. The story endured because no ordinary force seemed capable of producing something so orderly, so deliberate, and so immense. But the true origin of the Giant's Causeway reaches far deeper into time. Around 50 million years ago, this region was torn apart by intense volcanic activity. Lava erupted from deep within the earth and spread across the surface in vast sheets. Unlike explosive volcanoes, these eruptions were slow and persistent, flooding the landscape with molten rock. As the lava cooled, something remarkable happened. Basalt contracts as it cools, and when large volumes of lava cool at a uniform rate, the contraction creates stress. That stress must be released. The most efficient way for rock to crack under these conditions is not randomly, but geometrically. The result is columnar jointing, fractures that propagate downward, forming polygonal columns with astonishing regularity. Hexagons dominate because they are the most efficient shape for evenly distributing stress. Over millions of years, erosion stripped away the softer surrounding rock, revealing the columns beneath. What was once buried deep within volcanic layers became exposed at the edge of the sea, forming the landscape we see today. Walking across the Giant's Causeway is disorienting. The stones fit together too well. The patterns repeat with uncanny precision. Each step feels intentional, as if the ground were designed to be walked upon. Yet no hand shaped these stones. No intelligence planned their arrangement. It was physics. It was heat. It was time. The ocean continues to shape the causeway even now. Waves crash against the columns, slowly rounding their edges. Salt and wind wear them down grain by grain, but the geometry remains, stubborn and persistent, resisting chaos longer than almost any natural structure. The Giant's Causeway is more than a geological wonder. It is a reminder that nature does not always create disorder. Sometimes under the right conditions, it creates order so perfect that it challenges our sense of what is natural at all. Standing here between land and sea, past and present, it becomes clear why humans once believed giants built this place. Because when nature chooses symmetry, it can feel almost supernatural. On the edge of Middle Island, off the southern coast of Western Australia, there is a lake that immediately breaks the rules of expectation. From the air, it appears unreal. A smooth, continuous body of water dyed in a vivid shade of pink, bordered on one side by dense forest and on the other by the deep blue of the Southern Ocean. No gradual transition, no fading, just an abrupt clash of colors that feels deliberately painted onto the landscape. This is Lake Hillier. Unlike many unusual lakes around the world, Lake Hillier does not change color with the seasons. It does not depend on lighting conditions. It does not fade during storms or darken during droughts. Its pink coloration remains constant, year after year, an unbroken anomaly in an otherwise natural environment. For a long time, the lake's color was a mystery. Early explorers documented it with disbelief, suspecting chemical contamination or mineral reactions beneath the surface. But Lake Hillier is remarkably stable. Its waters are not toxic. They do not stain the shore, and despite their striking appearance, they do not behave abnormally when removed from the lake. The explanation lies not in pigments or pollution, but in light. Lake Hillier is extremely saline, far saltier than seawater. This high salinity creates an environment where only specialized organisms can survive. Among them are halophilic bacteria and microscopic algae, particularly a species known as Donaliella saline. These organisms thrive in salt-saturated water and produce red carotenoid pigments as a natural defense against intense sunlight. Over time, the combined presence of these pigments saturates the entire body of water, creating the lake's signature pink hue. What makes Lake Hillier especially strange is its isolation. A narrow strip of sand separates it from the ocean, yet the lake remains chemically and biologically distinct. Ocean water does not dilute it. Storm surges do not erase its color. The ecosystem maintains its balance with remarkable consistency, as if sealed in its own biological bubble. Standing near Lake Hillier feels disorienting. The color challenges instinct. Water is supposed to be blue, green, or clear. Pink water triggers disbelief. The mind searches for artificial explanations. Dye, waste, illusion, but none apply. This lake is alive. Its color is not a surface effect, but a property of the entire system. Every drop contains the same pigmentation. Every ripple reflects the same surreal shade. And yet, despite its alien appearance, Lake Hillier is harmless. Birds can land on it. Humans can touch it. The water does not burn, stain, or poison. The lake simply exists, in defiance of expectation, quietly rewriting what a natural body of water is allowed to look like. Lake Hillier reminds us that nature does not follow aesthetic rules. It does not care what feels normal. Under the right conditions, biology can transform an entire landscape into something that feels fictional. From above, it looks like a digital render. From the ground, it feels like a dream. And from any perspective, Lake Hillier stands as proof that reality does not need our permission to become strange. In the heart of central China, where mist drifts endlessly between mountains and the air itself seems suspended, there is a landscape that feels disconnected from Earth. Tall stone pillars rise vertically from the forest floor, stretching toward the sky like colossal monuments. Some disappear into clouds. Others stand in complete silence, isolated and impossibly narrow, as if gravity had briefly forgotten how to function. This is Zhangjiajie National Forest Park. At first glance, the terrain looks artificial. The formations resemble skyscrapers carved by design rather than erosion. Their shapes feel too precise, too dramatic, to be the product of slow natural processes. Yet every pillar, every ridge, and every cliff is the result of time acting with relentless patience. The story of Zhangjiajie begins more than 300 million years ago, when this region lay beneath ancient seas. Layers of sandstone slowly accumulated, compressed and hardened. Over vast spans of time, tectonic forces lifted the land upward, exposing it to the surface. What followed was not creation through violence, but destruction through persistence. Water seeped into cracks. Wind carried abrasive particles. Ice expanded within fractures. Roots pushed into stone. Year after year, century after century, erosion attacked the rock from every angle. Softer material gave way first, washed into valleys and rivers. Harder sandstone resisted, remaining behind as towering columns while everything around them vanished. The result is one of the most vertical landscapes on Earth. Some of these pillars rise more than 650 feet from the forest floor. Their narrow bases support massive stone bodies above, creating silhouettes that seem physically impossible. Fog frequently rolls through the valleys, obscuring the lower portions of the formations and leaving only their upper sections visible. When this happens, the pillars appear to float, disconnected from the ground, suspended in empty air. This illusion is so powerful that it reshaped popular culture. Zhangjiajie's mountains inspired the floating landscape seen in the film Avatar, blurring the line between fantasy and geology. But unlike fictional worlds, this environment continues to change in real time. Rainfall accelerates erosion, temperature shifts widen fractures, entire columns eventually collapse, not with sudden violence, but through gradual weakening that may take millions of years. What we see today is a snapshot, a temporary arrangement in an ongoing process of transformation. Walking through Zhangjiajie feels like moving through vertical space, rather than horizontal land. Trails weave between sheer walls of stone. Elevation changes abruptly. Sound behaves strangely, echoing between pillars and dissolving into mist. The forest below thrives in constant shade, fed by moisture trapped within the valleys. This place challenges the way we perceive scale. Human structures feel insignificant here. Towers and skyscrapers imitate forms that nature perfected long ago. And while cities rise and fall within centuries, these stone columns endure across epochs. Zhangjiajie is not merely beautiful, it is humbling. It reminds us that landscapes do not need symmetry to feel designed, nor chaos to feel natural. Under the right conditions, erosion can sculpt environments so dramatic that they appear unreal. Here the earth does not lie flat, it reaches upward, and for a moment it feels as though the planet itself is trying to touch the sky.